So function is the natural log 1 plus x, and the a is 0. Okay, function, the point a given approximate the natural log of 0.9. Number one, we're going to find the linear approximation. So we're going to need the a, which is 0, function at a, which is the function at 0, or the natural log of 1 plus 0, or natural log 1. That's nice. Natural log 1 is 0, right? That's cool. And then f prime at a, which is the slope. F prime of the natural log of 1 plus x. Use the chain rule. We have 1 over 1 plus x and multiply by 1 as the derivative of the inner function. If you forget, you are lucky for this problem. And then evaluate when x equals a or at 0. That gives us the f prime at 0 equals 1. We have a, we have the function at a, we have the derivative at the point a. So the linearization or the linear approximation function, which is from the function value plus the slope multiplied by the x minus the a. And the f at a is 0 plus the f prime, which is 1, multiplied by x minus 0, or it turns out to be the Lx equals x. That's nice. So this is the linearization or the linear approximation, or the line that we're going to use to approximate the nonlinear function value or the natural log 0.9. Step number 2, use this linear approximation to estimate natural log 0.9. Just pay attention to the form here. If you find the value of the natural log 0.9, compare with the function notation that we have. The f of x is the natural log of 1 plus x. Okay, 1 plus x. So if you compare what is the value of the x, you have to compare the log and the log notation. That means the 0.9 is 1 plus x, or we can say x equals 0.9 minus 1. It's not the direct form as we saw in the previous example. So this problem, the x we're going to use going to be negative 0.1. You see, our goal is to find the value of the natural log 0.9, while the last problem, we had to find the function at 1.1. So they are asking you like two different format of the value. Okay, just pay attention to this detail. So you have the log here, compare the input, and we'll give you the value of the x we're gonna use. Another way to check, since we're gonna need the good approximation, the x and a has to be very close and near. So the two x value has to be very close to each other. Otherwise, the approximation is not good. Excuse me. So we're gonna need to use x equals 0.1 for this problem. That means the natural log 0.9 will be approximately equal to the linear approximation at x equals negative 0.1. And the linear approximation is the equation Lx equals x. That's easy enough. The L of the x equals x, so the approximate of this natural log 0.9 is negative 0.1. And that's the answer for part 2 of this problem. Okay, let's check with the exact value. If you have the calculator handy, the exact value of the natural log of 0.9, that should be very close to the negative 0.1. I have the negative is about negative 0.105360 5157 and so forth. So we have the very close number to the negative 0.1. That's a good sign again. Okay, that means we are in a good in the right direction. And the last part of the problem, you find the percent error. Okay, percent error, which is the relative error in the form of the absolute value of the approximate, which is negative 0.1, or the L at x, minus the exact, which is the natural log of 0.9, divided by the exact natural log 0.9, absolute value multiplied by 100%, and get the number out as 5. I get 5.09%. This time we have the approximation is about 5% off from the exact value. The function is natural log of 1 plus x, and we are going to approximate the natural log 0.9. If we look at the point, let me see, the point that we're going to use is the point 0, 0. Okay, 0, 0. Let me see. The point 0, 0. And the line that we get, which is the linear approximation line, Lx equals x. The line passing to the point 0, 0, which is the shape point with the curve natural log 1 plus x. And we're going to use the line, the green line here, or the value of the function on the green line to approximate the value of the natural log 0.9. For the natural log 0. The value, let me see, um, negative 0.1 and the f at the value on the curve, that's supposed to be the value negative 0.10534 and so forth, that what we use from the calculator. I do see the red dot there. That's supposed to be the exact point on the red curve, or on the curve of natural log 1 plus x. And we use the value on the line at the same x value to approximate, which is negative 0.1. As you see, the blue dot and the red dot are very close as we zoom in. So you see the difference is a gap. So that means that's the error. So that's about 5% off from the exact value. But if you look at the bigger window, it's almost the same. So that's the reason that we use the line to approximate when the A 0 and the X negative 0.1 are very close to each other. Okay, use the line to approximate the function value of the nonlinear function.